Hi everyone, it's Tuesday the 19th of May and here is our maths learning for today. Our learning objective is to understand and calculate the area of quadrilateral shapes. So we're going to look at the area today. So that's different to what we looked at yesterday, where the perimeter was the boundary of the shape, and then the area we're going to look at the inside of the shape. Okay, so in year 4, you learnt to find the area of rectangles just by counting the squares inside of a shape. So for example, the one here says to work out the area of the rectangle, multiply its length, the long side, by its width, the short side. So as I said, in year 4, you learnt just to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. But then in year 5 and year 6, we abbreviate that to this particular formula here. So length times width equals area. And then we've abbreviated that even more to L times W equals A. So remembering this formula is going to be really important for today, finding the area of particular shapes. Okay, and then when we write our answer, we would write, or in this particular example, it says 21 centimeters, and then there's a little floating 2, which means squared. And that we have, when we're dealing with area, we have to write the little 2 as when we're writing our answer, because that just tells us how many squares fit inside that shape. Okay, so now we're going to look at some questions, but obviously in the questions in year 6, they're not going to have the squares inside the shapes for you to easily count. So that's why it's really important that we remember to use that formula. Length times width equals area. Okay, so in these basic squares and rectangles, we can see, if we look at this first one, here's our length, and then we've got our width. So all we would need to do in that particular calculation is 6 times 3 equals 18. And then we would put in our units of measurement, centimeters squared. So that tells us that 18 squares fit inside that rectangle. Okay, now moving down to this particular calculation, the length is always the longer side. So this is our length of this shape, times the width. Okay, so then we would write 9 multiplied by 5 equals 45. And then put our units of measure in, centimeters, and then because we're dealing with area, we must show the squared. So there are 45 little squares that can fit inside that particular rectangle. Okay, next shape, we've got a square. So it's 6 multiplied by 6. The length and the width are the exact same. That's what makes it a square. So 6 times 6 equals 36. And then our centimeters squared. So 36 squares can fit inside of that square. Okay, next one, we've got our length times our width, 8 multiplied by 2. So 8 times 2 is 16, so therefore our area is equal to 16 centimeters squared. 16 squares can fit inside that rectangle. Okay, then our last one, even though it looks like a square, we can see that it's not because it has our length here is 8 centimeters, and then our width is only 7 centimeters. So even though it looks like a square, it's actually a rectangle. And then 8 times 7, length times width equals area, is area equals 56 centimeters squared. Okay, so lots of questions today are going to ask you to find the area of rectilinear shapes, which we started looking at yesterday in our perimeter lesson. So the example I've got here is a rectilinear shape because we know from yesterday a rectilinear or compound shape is a shape that's made up of rectangles and squares. So as we can see here, we've got this whole shape, but it's been split into 2 rectangles. And if we can do that, then we can still use the formula length times width equals area. but it's just a case of finding where the length of that particular rectangle is and where the width is. So starting with the bigger rectangle, we can see that the length here is 12 meters and our width is 6 meters. So it's all about just finding a length and a width of that particular rectangle only. Obviously, we wouldn't use the 9 meters because that is the length of this whole side, and that's more than we need. So just the length and width of the rectangle we need. So as we can see here, 12 meters times 6 meters is 72 meters squared. So that would be the area of this rectangle. And then again, with our smaller rectangle, finding the length and the width of that particular rectangle. And then again, using the formula, length multiplied by width equals area. And we can see here 6 meters times 3 meters equals 18 meters squared. So 18 squares that are meter by a meter can fit inside that rectangle. And because it's obviously we've split it into two parts, we then need to add those numbers together to find the area of the whole rectilinear shape. So all we would do is 72 meters squared add 18 meters squared equals 90 meters squared. So for this whole rectilinear or compound shape, the area is 90 meters squared. Okay, so now we're going to look at two different rectilinear shapes and we're going to try and find and solve the area of that particular shape. So a bit like yesterday, we're going to need to make sure we've got all the sides because that's going to really help us understand and which numbers to use. So in our first one, again, like yesterday, going to start with a corner and check the length of all the sides. So I've got 16 centimeters along here, 4 centimeters, and I've got a missing one, then 5 centimeters, 13 centimeters, and a missing one. So I've got two missing lengths that might be crucial to working out the area. Okay, so I can see, again, looking for parallel lines, 16 meters squared at the top here, and then I've got 16 centimeters at the top and 13 centimeters at the bottom. So that 13 is part of that 16. So using almost like a bar model, 16 is at the top and it's made up of 13 and something. And then that something will be 3 centimeters. So if I've got 16, 13 and 3. So then here must be 3 centimeters. Okay, then I've got the missing side over here. Again, I'm looking for those parallel lines. So this would be a parallel line and this would be a parallel line. So that's 5 centimeters plus 4 centimeters, which would be parallel. The total, again, using a bar model, I've got 5 centimeters plus a 4 centimeters. That would equal a 9 centimeters. So the length over here is 9 centimeters. Just like yesterday, all the information that's provided in the questions, you will have enough information to solve the question. They're not going to make you pluck out a number out of your head. Okay, so now I'm going to split my shape into two either rectangles or a rectangle and a square. So I'm going to split it here. I could split it this way, but I'm looking for the easiest ones to work with. Okay, so I'm going to get rid of that. Okay, so now I'm looking for a length and a width. So 4 centimeters multiplied by 3 centimeters would be 12 centimeters squared. And then, so that would be the area of that small rectangle there. And then I know I'm looking for a length and a width. So 13 multiplied by 9. So again, I might 13 multiplied by 9, use a short multiplication method because that's not always as easy. So 3 times 9 is 27, 1 times 9 is 9, plus the 2 is 11. So the area of this rectangle now is 117 centimeters squared. So I've got the area of 2 rectangles, but now I need the area of the total. So I need 117 add 12. 7 add 2 is 9, 1 add 1 is 2, 1 add 0 is 1. So the total area of this rectilinear shape is 129 centimeters squared. Okay, let's try with a different one. So the next question here. So I'm going to just quickly go round, starting from here, make sure I've got all my lengths. So 32 centimeters, I've got a missing one, 24 centimeters, 20 centimeters, a missing one, and 6. Okay, so working on this length here, I'm looking for those parallel lines, which would be this one here and this one here. So 20 plus 26, 20 plus 6 is 26. So that's 26 centimeters, because that's just the length, not squared, because we're just looking at the length of the boundary of the shape, so the perimeter. And then I've got a missing piece here, so I know that my total would be 32. And I'm looking for those parallel lines, so my 24 would be at one part of it, and then I'm looking for another part, which is my missing bit. So 32 take away 24 would be 8. So our missing length there is 8 centimeters. Okay, so now I've got all of the lengths for the perimeter of the shape. I now need to split it. So I've decided I'm going to split it this way. So then I've got 2 very clear rectangles, one sort of chunkier and one long thin one. Okay, so now I'm looking for the length, so 32 centimeters multiplied by 6. So I can quickly do that. 32 multiplied by 6. 2 times 6 is 12. 3 times 6 is 18, plus the 1 is 19. So the area of my long thin rectangle is 192 centimeters squared. Okay, now finding the length and the width of my second rectangle, I'm going to do 24 times 20. Okay, because it's a multiple of 10, I don't really need to use a calculation for this. I could probably do this one mentally. So I could do 24 times 2, which is 48, and then times that number by 10, which would be 480. So I know that the area of this part of the shape is 480 centimeters squared. Again, I've got 2 numbers now, so I need to make sure I add them together to find the area of the whole of the rectilinear shape. So I need to do 192 add 480. So 2 add 0 is 2, 9 add 8 is 17, 1 add 1 is 2, plus the 4 is 6. So the area of the total of the rectilinear or compound shape is 672 centimeters squared. Right, and then here we have our star activity, so our 1-star, 2-star or 3-star activity. I would recommend trying to have a go at all of it, but it is entirely up to you. Obviously it progresses through the star activities, and with 3-star having some quite challenging, really challenging your knowledge of area. So good luck guys, and I hope to see some of your learning. Okay, speak to you soon, bye.